So that's the end of the nomenclature section of this chapter, and then we go on into, well, it's kind of related, but it's kind of a different topic as well. So formula mass. These chemical formulas tell us how the elements are combined, the numbers of atoms of each element that are combined together in an individual molecule or formula unit. The formula mass is the average mass of an individual molecule or formula. It's sometimes referred to as a molecular mass or a molecular weight. And what we're talking about here is at the atomic molecular level. We're not talking about moles yet. We're talking about like a molecule of water, H2O. How much does one molecule weigh? The reason we call it formula mass is because ionic compounds don't have molecules, right? Ionic compounds, we talk about their formula unit, the smallest whole number ratio of the ions. Okay, so here we have what we do to find the formula mass is we just add up the masses of the atoms in a single molecule or a formula unit. Okay, so the number of atoms of the first element times the mass of each atom of that element plus the number of the second times its atomic mass, etc. It's like taking a box of bowling balls, and there's 3 10-pound bowling balls and 1 8-pound bowling ball. How do you find the mass of the whole box? Well, you take the mass of each piece and you add them together. If there's 3 10-pound bowling balls, then you've got 3 times 10 is 30 pounds from that, plus the 8-pound ball, 38 pounds. That's exactly what we're doing, but here instead of bowling balls, they're atoms. So what's the formula mass for calcium nitrate? What do we need first? We need the formula, right? And I've taught Chem 3A, which is a class a level below this, but covers many of the same topics. I've taught Chem 3A many, many times. I haven't taught Chem 1A as often. One of the differences between 3A and 1A is that in 3A, we separate the topics a bit more. And in Chem 1A, we let them just all roll and bundle up together. So you could see a question like this on an exam. This is combining ideas of formula mass and writing formulas for the compound. And so it's not just one skill, it's multiple skills that are going to be grouped together. And that's what's expected of students in Chem 1A. So we need the formula for this. What kind of a compound? Look at the first element. Is it a metal? Calcium is a metal. That makes this what? Ionic. So ionic, first we need to write the formula of the cation and the formula of the anion and look at their charges so we can put them together. So what's the formula for a calcium ion? Ca2+. We know it's 2+ because it's in group 2 on the periodic table. What's the formula for nitrate ion? NO3 with a -1 charge. Okay, if you're still a little shaky on your polyatomic ions, now is the time to get on the stick with learning those. Flashcards are a great idea. So to combine these, we're going to end up with a formula of what? Yep. We need 2 of these guys to balance the charge on one of those guys. This is a polyatomic ion. We have more than one. And so we have to shrink wrap it, just like Costco does. And we've got this package deal. We got 2 of them for every calcium. Now that we have the formula, we can calculate the formula mass. We look at the formula, and we see we have 1 calcium atom. So what's the mass of 1 calcium atom? 40.078. Yeah, now periodic tables vary in the number of digits that they give you for the atomic masses. Some periodic tables, like the one I give you for the exams, they've rounded them all so that they all have 4 significant figures. And so a lot of times that's what I'm going to do on my examples, partly because I've memorized many of the atomic masses that way, and it's just a lot easier. So I'm going to call that 40.08. The mass of one calcium ion, what's the unit on that? AMU. It's not grams, because that would be a mole of calcium. And then, how many nitrogens do we have?
2.
2. So then we get the mass of nitrogen. And how many oxygens? 6. Because this, you can think of this as distributing. The 2 gets distributed, so we got 2 nitrogens and 2 times 3, 6 oxygens. So 6 oxygens, we look up the mass of oxygen. And then we get out our calculator. And we punch it through. I do not recommend rounding atomic masses more than 4 significant figures. Don't go down to 2. You're going to introduce some rounding errors, and Mastering Chemistry will get unhappy with you. So my calculator is showing me 164.1. The unit would be atomic mass unit. Different ways of thinking about significant figures. What do you think? How many significant figures should this number have? 5. If we're going to really follow the rules of significant figures, I agree. I think it should have 5. Well, just a minute. It gets messy. It gets messy. Okay, so 6 times 16 is 96. The 6 is an exact number. The 16 is not. So this should have 4. But what would happen if we had 7? We would get up to 112, and then we would lose a decimal place. Right? And so then that would affect the number of significant figures in the answer. So this is where things kind of get a little iffy. So there's basically 2 ways you could think about it. You can think about it and say, we are adding things here. Okay, we're just adding, and so if all of these have 2 decimal places, then we should have 2 decimal places in the answer. And I think that's very valid. And so you would then add a 0 here and say 164.10 atomic mass units. Another way that they tend to take in lower level chemistry classes is they say, well, all of these molar masses had 4 significant figures. We're going to round the total to 4 significant figures. I don't have a huge problem with that, but I think we'll just go with number of decimal places. So I hope that wasn't extra confusing. It probably was. Any questions? Being able to do something like this is really, really important. So that was formula mass. That's the mass of a formula unit. The molar mass is the mass of 1 mole of it. Okay? So what's nice about this, the formula mass, the molar mass, the number's going to be the same, only the unit changes. And we arrive at them in this by the same process. So let's do this one. What's the molar mass of ammonia? What's the formula for ammonia? NH3. So we're talking about 1 mole, Avogadro's number, 6 times 10 to the 23rd molecules. So that's going to have 1 mole of nitrogen. 1 mole of nitrogen would weigh 14.01 grams. And it's going to have 3 moles of hydrogen, 1.008 grams. and it's going to come out to 17.03, if I remember correctly. Yeah. Any questions? We can use the molar mass to count molecules by weighing them, just like we were using that to count atoms. So here, if we have a mass of A, we can figure out how many molecules of A there are. We need to go through moles first. When we were looking at individual atoms, we kind of had a shortcut. We can't use that shortcut when we deal with molecules because you can't just look at the periodic table and see what the molar mass is. Oh, we could still do it. What am I saying? We could still do it. This is the way it's traditionally thought of, that we always go through molecules. Oops. You could do this. Just like we did with, see that, doesn't that word need abbreviation? It really does. And here's the molar mass. It's sometimes called capital M, and that would be in grams. And so we can do that little shortcut. Basically what we're doing is we're putting the molar mass in here, but instead of 1 mole, we're putting in what it means, which is Avogadro's number. So if you like the shortcut, go ahead and use it. If it confuses you, don't. So nitrogen dioxide is a component of urban smog that forms from gases in car exhaust. How many molecules are in 8.92 grams of nitrogen dioxide? Well, what number are we given? 8.92 grams. Nitrogen dioxide, what's the formula for that? NO2. Because the di means there's 2 oxygens. So we're given grams of that. And what are they asking us to find? Molecules. Just like when you're planning a trip, you need to know where you are, where you're starting, and where you're going, right? Google Maps asks you that all the time. Where are you? Where do you want to go? Okay? You have to identify that before you can figure out how to get there. Now, there's 2 paths we could take here. Do we want to go straight from grams to molecules, or do we want to go through moles? Let's go through moles. This is what most people would do. So there's our path, grams to moles to molecules. And there's Dora with her giant head going off in search of something. So grams, and here we are, dimensional analysis again. Times, we have 2 arrows, we're going to have 2 factors. The units in our path are the units in our factors. So grams to moles to molecules, grams to moles to molecules. We place the units in the denominator, so they are going to cancel out. And this is this beautiful pattern we can follow for so many things. We get all the units in, then we need numbers. You don't have to do the first one first. Let's do the last one first. What's the relationship between molecules and moles? Yeah, it's Avogadro's number. So 1 mole, remember, mole is like a dozen, molecule is like an egg, right? It's 12 eggs in a dozen, not 12 dozen in an egg. So don't get that backwards. So the number goes with the molecules. And here we have the longest number and the longest unit, and they have to be together. Okay, grams and moles, this relationship. Where do we get that? That's the molar mass. We're going to use the periodic table, and we're going to calculate it from the formula. So we've got nitrogen, 14.01. We've got 2 oxygens, 16. And I would encourage you to do this. Actually write this out. Even though I know most of you could just punch it into your calculator and be fine. It's nice to have it there in case the answer turns out wrong. You can go back and look and make sure that you did that right. So this comes out to 46.01. Now that number means that there are 46.01 grams per mole of that particular compound. This molar mass here is not a final answer. If you have extra digits, don't throw them away. I think as a minimum, it's good to carry 2 extra digits all the way through until your very final answer. So in this case, there were no extra digits, so we're okay with the 46.01. It's 1 mole, and the number goes with the grams. In putting this into your calculator, I think the best approach is left to right, top to bottom. You start with 8.92 times the top, divide by the bottom, times the top, divide by the bottom, and that way you don't leave anybody out. We're expecting this to be a really big number, and sure enough it is. How many sig figs should our answer have? 3. Because the starting number had 3. The molar mass had 4, Avogadro's number had 4, and all we're doing here is multiplying and dividing. So 1.1, it says 6.7, so I have to round my 6 up to a 7, times 10 to the 23rd, and always put your units. Oh, I don't have space for that giant word. Molecules. On labs, which is the only place I see written out work, it's always a nice touch to put a box around your final answer. It makes it easier to find. Any questions? This should be old hat, but it's really important, and that's why we go over it.